Okay, so I have some additional explanation. Okay, here I think this is the thing. Here, okay, this is you can see this is the equation of the form describe spatial curve that change with time. Spatial curve. This is like a spatial surface. This is I think we can say this is like a curved surface. Okay. So this equation or this equation form describe the curved surface change with time, right? So if time changed by delta t, the coordinates have to increase by delta xi. Yeah, this is more or less particle. Okay, I think same particle. So because this, okay, so if you have some curved surface like this, so then there is a point uh, xi, okay, and at this point here, so this is uh, I I is 1, 2, 3 here in this case, okay, xyz, and this point you have a particle x. This is same particle, okay. So if time changed by delta t, this particle move, yeah, by delta xi. So by definition, and this partial derivative, I would say strange. This one you can replace delta xi, delta t. And this is exactly the velocity vi for particle x. And I don't think there is any ambiguity. So this is kind of strange. I don't say this. I just say delta. Yeah, so at any instance, this gives the rate of change of the coordinates of a point on this curve. If it is a material curve, this rate of change will be the velocity of the material particle. That is, from this we get the Lagrange criterion for spatial curve to be a material curve. Spatial curve to be a material curve. Anyway, I think we consider only material curve. Okay, we consider only material curve. then the point move just as a particle. If you have some material, then you have a point, spatial point, which is x, and this point move to another place by velocity vi, velocity v, and this velocity is the velocity for particle x. So this particle actually move to another point. That's a velocity. And this one, this thing is the velocity. So I think this is clear. Then we have a example, right? Example. So then we have a hyperbola as a path line. Path line is hyperbola, right? Then the next one is this streamline. Yeah, I think to consider streamline. See this one. I think we have from 264. See, I think we can see this. We can use this one. See this one, right? So then we have V1. V1 is just like cos t. Cos t, and this is x2. We also have V2. V2 is a sinh t. This is x1. So we have this relation. That's why we have this. V1 is x2, V2 is x1. Yeah. And streamline are tangential to the velocity vector. Tangential to velocity vector. So that means this one. I think we learned this equation. So then we place V2, this one, to here, and this one here. So we obtain this. Yeah, I think this is clear, right? So we obtain this one. We obtain this one. Then the question is how we solve this. How we solve this. So we have a point x, which is x1, x2. Yeah. And this one, let me see. We can assume this x1, x2 is a function of something, some parameter. So we consider this x1 is a function of some parameter s, x2 is also a function of parameter s. Then you can draw a curve because there is some point which is s equal s1, another point, this is x1, x2, another point is s equal s2. Then this curve is something we want to know. This is x2. Yeah. So we consider the following. Okay. Let me use whiteboard. I think it's better to use whiteboard. We want to know a curve. The curve described by this equation: x1 dx1 minus x2 dx2 equals 0, right? Then we assume, okay, this is a parameter of something, some function of some parameter. Okay, x1 is you just assume x1 x2 can be described using some parameter s. So there is a first point is x s1. Then you go to the next point. This is x s2, for example. Okay, so then you can write this equation as this: x1 dx1 ds, yeah, and minus x2 dx2 ds equals 0. Okay, so then you can integrate. Yeah, so you can integrate easy. Just put integration, and then s can go from s1 to s2. So second one you also integrate from s1 to s2. Okay, so then this integration can be done easily. The answer is you have x1 s square s1 to s2 minus, sorry, x2 s square, you go from s1 to s2 equal 0, right? So you can put s2 x1 s2 square minus x1 s1 square minus x2 s2 square minus x2 s1 square equals 0. Yeah. But then we assume, okay, from first point is 1. Let's see. We can assume x1 s1 x2 s2 x2 s1, this one, let this be a position at t equals 0. So that means x1 s1 equals 0, x2 s1 equals 0. Yeah. So we have, no, this is 1. So this is 0, this is 1. So x1 s2 square minus x2 s2 square equal minus 1. Is it same? 2, oh, yes, okay. So we just rewrite this one. x2 s2 square minus x1 s2 square equal 1. And now s2 can be anything. s2 can be anything. So we drop it. We just drop it. So then we obtain x2 square minus x1 square equal 1. So this is the streamline. Streamline. Okay, this is the streamline through 0, 1 at t equals 0. So we obtained it. Now we obtain the streak line through 0, 1 when t equals 1. To identify all particles that would visit the spatial location 0, 0, 1 in time tau. We invert 624 and substitute x1 equals 0, x2 equals 1 to get how do you invert it? I'm sorry, I don't remember the exact meaning of streak line. Streak line are curve representing locus of material particle at time t that would pass through or would have passed through a given point x star. the particle that will be at x star at time tau is identified as x star is x oh my god. Streak lines are curves representing the locus of material particle at time t that would pass through. Streak lines through 0.1 when t equals 1 to identify all particles that would visit spatial location 0, 1 in time tau. We invert and substitute. How do we invert it? We invert this one. Let me see, how do you do this? We have x1, x2. This is a cos, sinh, cos, large x1, large x2. Cos, yeah. So this is, can we invert this same 1, 2? Is it correct? Cos, sinh, cos, small x1, small x2. Is it correct? Cos, sinh. I think there has to be minus sign here. Cos. Yeah. So x1 I have a very tough I have very tough time understanding the difference between tau and t. Anyway, so we have x1 is cos t, x1 minus sinh t, x2. Then let me delete this. Then we have x2 is minus sinh x1 plus cos t x2 t x1. Yeah. Then the point is when t equal 1, okay, we have when t equal 1, 0, 1, 0, 1, t equal 1, then x1 is 0, x2 equal 1. Let me see. I didn't understand very well. Let me think a little bit more. So I think I need some time. So let me stop